immune benefiting ingredients, which are important for the offspring's survival. Because remember, the offspring, the baby, their immune systems are immature and naive, and they haven't been exposed to all the health threats, right? And so they need that knowledge that the mother already has with these existing health threats. Okay? Okay, now that we understand the purpose of transfer factor, let's look at kind of the composition of these transfer factor sources. So bovine colostrum is a complex mixture of fats, carbohydrates, proteins, growth factors, enzymes, enzyme inhibitors, nucleosides, cytokines, fats, vitamins, and minerals. You got that? That's going to be on the quiz at the end, okay? Now, the point is that colostrum is highly complex. Very, very complex mixtures, complex samples. And so for us to get transfer factor out of that, and for us to study transfer factor, you have to use highly sophisticated equipment, highly sophisticated filtration procedures, because it's a very complex mixture, okay? And we want it, and we have all that because we want to make sure that we have peak production of transfer factor, fresh, rich, bioactive sources of transfer factor. Now, egg yolks make up about a third of the weight of the egg, and it provides a rich source of macronutrients such as fat, carbohydrates, and proteins. And it really is to give sustenance to the chick. It also functions as a good source of vitamins and minerals. Okay? All right, so we can utilize our knowledge of these immune benefiting ingredients and advanced testing methods to be able to monitor these as they pertain to the mother's passage of the immune system to the offspring. The majority of these immune benefiting substances are called immunoglobulins. And Dr. Brock's going to talk a little bit about the immunoglobulins when she gets up here and talks about how transfer factor works. And for colostrum, there's an immunoglobulin called IgG. And it makes up about 80% of the proteins out in colostrum. For egg, there's an immunoglobulin called IgY, which is coming from the egg yolk. Now we can observe the transfer of these immune knowledge, these immune benefiting ingredients from the mother to the offspring by following IgY and IgG. Okay? And this information allows us to optimize, to make sure that when we get transfer factor out of the egg yolk or out of the colostrum, that we're getting the freshest, richest source of transfer factor. Okay? Does that make sense? And we can do that at the farm level, right? We can monitor these processes by each farm where we get colostrums, okay? All right, so as you might have learned, as we just mentioned, that transfer factors are small peptides and proteins, and they're used to educate the immature immune system of the newborns to be able to recognize. Now, you guys should know this part, right? So let's say it all together. Recognize, respond, and remember, right? Recognize, respond, and remember. Now, these proteins and peptides are made up of large molecules and small molecules. And the immunoglobulins, by comparison, are very, very large, right? Dr. Vaughn, we talked a little bit about the size. Calvin came up here and scared everybody. Transfer factors are small, immunoglobulins are large. And so the process to obtain transfer factor out of colostrum, right? Colostrum is highly complex. And so we need really special procedures to obtain those. That involves several steps. It involves defatting the colostrum, right? There's fat in colostrum. It involves pasteurization. We want to get rid of all these environmental threats that might be in the colostrum. It also involves concentration through these very fine filters. And that's really the key here, is that concentration step. Because we want to take these small molecules, these small peptides and proteins, and extract them out of colostrum, so that we can have this fresh, rich source of transfer factor, okay? And then after that, we go from a liquid state, right, because this is all liquid, and then we spray dry it into a powder. And the powder we can put into capsules, right, into our products, okay? Does that make sense? Now, what's really cool about this part is that this is a very cutting-edge, very sophisticated way to get transfer factors out of colostrum. In fact, it's so cutting edge, it's so sophisticated, that we have patents around how we do that. And do you know what that does for us when we have patents around that? It protects our formulas, it protects our process, it protects our way to get transfer factor so that nobody else can do it. helps us create exclusive products that nobody else can make. And so when you go out and you sell transfer factor, and you talk about transfer factor, you talk about the story, you can talk about this and you can be proud of it because nobody else has it, right? It allows us to differentiate ourselves from everybody else because nobody has transfer factor like for life, right? Okay. Now, getting transfer factor out of egg is a little bit different. It's a slightly different process. And in the simplest terms, we get transfer factor by what we call phase separation. And this is, in simplest terms, this is just taking the egg yolk from the egg white and the shell and carrying along all these immune benefiting ingredients through the egg yolk. And so that's how we get it from chicken egg yolk. Okay, now let's shift gears a little bit and let's talk about how we study it, how we characterize it. Because that's really important for customers and distributors alike so that you get the most bioactive forms of transfer factor, right? These immune benefiting powerhouses. And we call this area of science transfer-suitable science. And really what that means is that it's the characterization, the exploration of the activity of transfer factor. Okay? And in part 4 of this series, Dr. Brock is going to talk a lot about the activity of transfer factor. How does it work? How do we show that it works? Okay? And we do this in 3 different ways, the characterization part. We do this within regards to the composition of transfer factor, the size of transfer factor, and the identity. Right? The identity of transfer factor is really important. We've been doing a lot of work on that. And we use 3 different types of techniques. We use amino acid analysis. That gives us composition. We'll talk about that in a second. Right? Does everybody know what amino acids are? Okay, building blocks, right? Think about it, building blocks of peptides and proteins are amino acids. And so we do amino acid analysis to find the building blocks of transfer factor. We also have size exclusion chromatography, and that gives us information on the size, right? We talked about the size. And then we have this new area of emerging research called proteomics. And that really helps us identify what transfer factor is. Okay? All right, so let's go through each one of these. So amino acid analysis is utilized to determine the composition of transfer factor, right? And so we do that. The process is that you take these peptides and proteins, you break them apart in very specific spots, and that releases amino acids. And then you can take these amino acids, these liberated amino acids, and you can use chromatography to separate them, to detect them, and to quantify them. And that gives us information on the composition of transfer factor. And so you can look at these graphs and you can see that the composition of transfer factor, and from colostrum and from egg, right? We have ovofactor, ultrafactor, and nanofactor, and the composition is very similar. Now, interestingly, these amino acids are ones, some of these amino acids are called essential amino acids. And they're ones that our bodies can't make. We have to acquire them through the diet. And it's interesting and it's important to know that we have 9 of these in transfer factor, right? So you're getting essential amino acids when you take transfer factor. Did you ever think about that? I mean, when you think about amino acids, usually you're talking about whey proteins and that sort of stuff, but it's the same concept with transfer factor, right? We have amino acids, you're getting essential amino acids from transfer factors. Okay? All right, now let's switch on and go to size exclusion chromatography. So amino acids give us information on composition, but what about size? What about molecular weight? Right? Dr. Vaughn talked a lot about the size of transfer factors. Well, you will recall that we extract transfer factor out of colostrum, out of egg, right? And there's all kinds of immune benefiting ingredients in there, and they're all different sizes. And so we want to be able to study transfer factors, which are the smaller ones, right? And so we utilize this technology called size exclusion chromatography to monitor this process. So this is a chromatographic method in which biomolecules in complex solutions are separated and analyzed according to their size, right? We can separate out these complex samples and then study them based on their size. And in the case of ultrafactor, nanofactor, and ovofactor, we look at that in terms of 10 kilodaltons and 5 kilodaltons. Okay? So, colostrum and egg yolk contain many different proteins, right? Very complex, and they're varying in significance, right? We have the immunoglobulins, which are the larger molecules, and then we have the transfer factors, which are the smaller molecules. The immunoglobulins are usually over 20,000 kilodaltons, whereas transfer factors are less than 10 kilodaltons. So we can look at these graphs here, and we can see two graphs, right? These graphs are called spectra. And on the top spectra, that's what a size exclusion chromatography experiment looks like when you look at colostrum. And you see these peaks and these valleys, kind of like these mountains. Those are the large, on the upper graph, those are the large immunoglobulins, right, that make up the protein content in colostrum. And if you go to your right a little bit, I'm going to see if I can use my pointer here. If you go right over here, right, that part there, you see a little bump, right? For those of you over here, we have a little bump right there, right? That's transfer factor. Not very much, right? And so we need these really sophisticated extraction techniques to be able to pull that transfer factor out of colostrum. And so when we do that, when we utilize these techniques, this is what we get down here. See how the immunoglobulins are gone now? The large molecules are gone, and now we're left with the small molecules. And this is their filtered colostrum. So this is the ultrafiltered. This is the ultra factor. Okay? Does that make sense? Does everybody see that? Does everybody understand? So size exclusion allows us to interrogate the size of these molecules. Okay? Now, why is that important? Well, again, we want to be able to understand these at a molecular level. We want to be able to understand that we are getting the best transfer factor out of our colostrum. And this is one technique that we use to do that. Okay? Everybody got that? Okay. So now we know a little bit about the composition. We know a little bit about the size. What about the identity? What is these transfer factors, right? What's their identity at a molecular level? What are they? And we use a technique to do that called proteomics. And it's similar to size exclusion in the sense that we are separating out these very difficult components in colostrum, and then we can get what we call a chemical fingerprint. Because when we detect them, so we've separated them, and then when we detect them, we can get a chemical fingerprint, a biomolecule fingerprint. And that essentially is a way for us to identify what these transfer factors are, if we know them. Right? You kind of have to, with any fingerprint, you have to know who the person is. If you don't know who the person is with a fingerprint, you may not be able to identify it. And it's the same concept here. And then we can identify these by taking that fingerprint, putting it into a large database of known peptides and proteins to help identify the transfer factor. Does that make sense? Okay, so this is an identification technique. All right, now, this is really highly technical stuff. Very, very sophisticated instrumentation. And so for us to do this, we have to work with a lot of different universities to be able to interrogate transfer factor at the molecular level. And so we've worked with University of Utah, we've worked with Northwestern University, we've worked with University of Minnesota. We're just getting ready to work with the mass spec facility at the University of Colorado, because they have this sophisticated instrumentation to be able to study and identify these small bioactive peptides. And they also can provide clarity for what some of the unknown peptides are. Okay? All right. Oh, God. Oh, great. All right. Okay. Everybody calm down. It's okay. All right. All right. Okay. Ladies and gentlemen, Calvin Jolly, VP of Corporate...
Listen! Dr. Wollmer, first of all, you're stealing my look. All I got is this. You got a PhD. Don't steal this from me. Now, every time Dr. Wollmer says, do you get it? I'm like, no, I don't get it. And every time Dr. Wollmer says, is it simple enough in the simplest terms, and then it's very confusing to me. Proteomics, this, that, and the other. Will you please, maybe go back a slide and do a bit of clarification for us? Por favor, y lo siento, mi español es muy malo. Lo siento.
Okay, Calvin Jolly, everybody. yelling a little bit ago. Raise it. Okay. Well, did you know that when I went backstage before I came on, that there were some production folks who were ready to tackle Calvin? Did you know that? He scared them too. We didn't know this was happening, so we're kind of ad-libbing here. So anyway, so Calvin, if I understand your question, because I don't speak Spanish, I think you want me to simplify this, right? What does it mean for the average distributor for us to do all these experiments? And I hope what you get out of this is you don't have to understand proteomics, you don't have to understand size exclusion chromatography. I mean, I would love to be able to talk to you all day about it because it's really what I'm interested in. But for the average customer, the average distributor, what's really important is to know that 4Life cares very, very much about the quality of our products. We care, that's right. The quality of 4Life transfer factor is, I mean, it's a special ingredient, right? It's very special. It's something that 4Life has had for 20 years. It's what they built the company on, right? And we take that very seriously. And so it's important that we use these highly sophisticated tools to be able to understand it, to characterize it, to know it, to identify it. Because when we have that knowledge, it's like everything. When you have that knowledge, you can do better things, right? When you have knowledge, all the stuff you're learning right now is giving you knowledge. So when you go out and you want to talk to people about what transfer factor is, you now have that knowledge, right? And that's what we're doing. We're trying to get that knowledge so that we understand from a quality standpoint, from at a molecular level, from an identity standpoint, what is this transfer factor? What makes it so special? And what makes it so different? Thank you. And that's what's important, right? It's not so much the proteomics. You don't have to understand that. You don't have to understand size exclusion or amino acid analysis. But you have to understand that we take this so seriously. This is so important. The quality and being able to understand transfer factor and be able to make advancements on transfer factor, make it better, find new forms of transfer factor. All that sort of stuff are things that we work on, and these are all the tools that allow us to do that. So if that's all you get out of my presentation, then I'll be happy. If you want to come and talk at the R&D booth about proteomics, we can talk a lot more about that because we do so much stuff. We're only telling you a little bit about what we have done in the interest of time, but we have so much research, so much quality put into transfer factor that it's unlike anything you're going to get anywhere else out on the market. And that's why we do this. Okay? Does that help you, Calvin? Calvin, did I answer your question? Okay. So I know if I've been able to help Calvin, I've probably been able to help everybody else. So that's something to be proud of. Okay. All right. Should we move on? Okay. Well, how about we summarize? That was a good stopping point for me. So let's summarize. So 4Life transfer factor is comprised of small peptides and proteins from what? Colostrum and egg, right? It's made by the immune system for the immune system, right? Okay. We also have patented technologies that allow us to extract transfer factors out of colostrum as well as egg yolk, and we utilize state-of-the-art tools like proteomics, size exclusion, to be able to characterize them. And here's the real interesting point, because people ask me, do you know everything about transfer factor? And I said, well, we know a lot, but we don't know everything. Because what we found, what was interesting is some of the proteomic studies we did, while we were able to identify a lot of the peptides and proteins that were in the sample, there were thousands of peptides and proteins that were not identified that we believe are transfer factors. And we now have the tools to be able to move towards identifying those. In fact, when we did that study, there was thousands of peptides and proteins that wasn't in the database. And when we did what we call a de novo search, which is a fancy term of trying to identify these without any information, there was 35,000 different possibilities that these might be in terms of the amino acids and the peptides and proteins. Okay? So there's still a lot to learn about transfer factor. Okay? Is everybody with me? Everybody on? Okay. All right, now I think we are going to ask a question. So do we have somebody to ask a question? Can we have a raise of hands? Who wants to be a scientist? Who wants to come up on stage and answer science questions? Well, there's not very many hands. Come on! Don't make Calvin come back up here again. I don't...
Sí.
Oh, we got somebody. Okay. All right, good. And these are easy questions in my mind, so let's see how good a job you've done. Okay, and tell me your name. And let's ask you this question. Are you ready? Where are you from first? Colombia. We have Colombia? Okay, all right. Looks like we have someone from Ecuador. Okay, first question. Oh, and we got another one. All right, so we got 3 people. You can phone a friend. You can get together and figure out what it is, or you can ask the audience. Okay? I'll give you whatever you want to do. Okay, so first question, let's read it. What process does 4-Life use to extract transfer factor from cow colostrum? Is it A, distillation? Is it B, fractionation? That sounds... Is it C, ultrafiltration? Is it D, crystallization? Okay, what do you think? This is going to be a contest. We're going to see who gets it right.
I think that answer is C, ultrafiltration.
Okay, all right. You sure about that? Is that your final answer? Okay. How about you? What's your answer?
En español.
B? Fractionation? Want to ask the audience? How about we ask the audience? Trace? Okay, so we've got 2 C's. Feeling pretty good about that one. Okay, now you look really confident. Are you confident? Okay, what do you think it is? C. C. Okay, let's find out. Is it A, distillation, B, fractionation, C, ultrafiltration? That's what everybody thinks. Or is it D, crystallization? Ready? Ultrafiltration. Wow. That's great. That's awesome. Okay, now there's still another question. One more question. Can you do it? Okay. All right. Name one of the 3 ways. We should actually do this. You name one, you name one, you name one. One of the 3 ways we characterize transfer factor. Remember how we talked about how we look at its composition, its size, its identity? Okay, one of 3 ways. Okay, what do you think?
Proteomics.
Proteomics. Ooh, that's pretty good, huh? Okay. How about you? He said proteomics, you gotta come up with something different now.
Repítame la pregunta, por favor.
I don't know what that means.
Repeat the question, please.
Let's ask the audience again. Okay. Can somebody help her? Oh, here we got a translate. Okay. The question was, name one of the 3 ways that we characterize transfer factor.
Proceso de colostrum.
Size.
Process of colostrum, she answered.
The process of colostrum. Okay. Processing of colostrum, okay. That's not a way that we characterize it, but that's okay. There's 3 ways we talked about at the end. Okay. I'm gonna go over, this guy's Googling it, so, no, you can't look at your slides. No, you're cheating. This guy, you can't cheat like that. Come on. All right, one of 3 ways, okay? We already said proteomics. That's the toughest one in my mind, right? Who's heard of proteomics before this? Probably not very many people. So that was off the board, right? So now you got the other ones. What do you think?
Size exclusion,
You have to say it correctly.
size exclusion, chromatography.
Whoa! You got it! That's awesome! Okay, she's ready.
Tamaño.
You're saying size exclusion chromatography also? This
No, ácido o composición.
That's right! Amino acid composition! Can you believe it? That's awesome! So let's check it. Let's make sure. Science extrusion chromatography, proteomics, amino acid analysis. That's good. Thank you so much. That's great. Thank you. Thank you. Good job. Thank you so much, and I appreciate your time.
Ladies and gentlemen, please welcome to the stage Dr. Paula Brock.
For almost 5 years, and it's my great pleasure to conclude our session by presenting to you a lot of the research that we have done on for life transfer factor. You have learned so much so far this last hour and a half that you'll be sitting and learning all the different aspects of transfer factor. So before we start this last part, let's do a little bit stretching, shall we? So let's just stretch our arms up. We're gonna breathe in, arms up, stretch, reach to the ceiling. And breathe out, arms down. Let's pick up some energy here. Breathe in, arms up. Raise the arms up all the way, touch the ceiling. Breathe out, relax the arms. The last one. 100%, give it 100%. Breathe in, feel your lungs stretch. And relax, arms down, and we can take our seats. Okay, so this last part, we're going to learn a lot of the research we have done on for life transfer factor. Not all of it, just some of it. And in general, we'll learn how for life transfer factor works. How is for life transfer factor affecting your immune system and strengthening your immune system and improving your health. We'll first learn that for life transfer factor balances immune system response. We'll learn that for life transfer factor affects specific immune cells, the natural killer cells, macrophages, and the cytokines, which are substances that immune cells are releasing in their surroundings to kill that threat. We also learned that for life transfer factor affects the immune memory molecules that you learned with Dr. Parker in part 1, the immunoglobulins, the antibodies. And we will at the end learn that all those immune benefits of for life transfer factor is actually starting in our gut. That we have learned that 70% of the immune system is right in our gastrointestinal tract. So I want to start by presenting some of this data, some of the research we have done to understand how for life transfer factor helps our immune system respond to the threats. Those were one of the first studies that for life has performed. In order to understand how for life transfer factor helps the immune system respond to threats, we studied the natural killer cells. If you remember from Dr. Parker in part 1, the natural killer cells are great communicators of the immune system. It's that type of cell that is communicating between the two types of immunities that you learned, the delayed and the immediate immunity. But most importantly that I want to remember is the natural killer cells are the most important, the main cells that will attack and get rid of defective cells. If we have any cells that are part of us, but they are damaged, the natural killer cells will be the first ones to attack and to clear those cells from our body, okay? So this was the first study was conducted back in 2003. Healthy participants, healthy adults, were used in this study, and they provided samples We collected blood samples from those participants. And those samples were then taken to a laboratory, and they were exposed to damaging cells, to those defected cells that we want to test if our immune system can attack, specifically the natural killer cells. Then some of those samples were exposed to different for life transfer factor products. 48 hours later, so a very short amount of time, we measured what happened. We measured the activity of those natural killer cells. So let's see what we found. We first found that for life transfer factor classic product increased the activity of the natural killer cells by 204%. When we tested the samples with 4-life transfer factor trifactor format, we saw an increase in those activities of the natural killer cells by 283%. And with the 4-life transfer factor plus trifactor format, we saw an increase in 437%. All in comparison to cells that were not treated with 4-life transfer factor. Yes, that's great. Those are amazing results. So amazing that we want to repeat them. We wanted to replicate those studies, and recently, only last year, 2018, we concluded another study that used a much more modern technology than that study that was performed in 2003. Very similar to the first 2003 study, we used healthy participants, healthy adults provided the samples. And in the laboratory, we exposed those samples with those damaging cells. And 48 hours of treatment with 4-life transfer factor classic, we measured the activity of those natural killer cells. Okay, I want to all get very excited now because this is the first time that 4-life Research and Development team is sharing this data. Okay? So let's see what happened. This very modern technology that we used, it's called flow cytometry. It's this big box that is shown here on this slide. But more interestingly is the data that we get from this instrument. This image that you see on your right, this box, has many, many dots, right? Some dots are green, some dots are red. Each dot represents one cell. So you see there are a lot of different cells in that box. And I want to make this a little larger so we can understand what is happening. So that box in the middle was from a sample that was not treated with 4-life transfer factor. We see a lot of the red cells, but also a lot of green cells. All those red dots are the natural killer cells. And all the green dots are the damaging cells, the target, the threat that we want to destroy. Now, what do you see 48 hours later? So that image to the right. 48 hours after treatment with 4-life transfer factor classic. You see that all those red dots, all the natural killer cells, spread it throughout. They're all activated. They grow. And what we see with the green dots that are the target, the threat that we want to destroy. We see almost none of them. So that visually shows to us how 4-life transfer factor, classic in this case, only 48 hours of treatment, increased the activity of the natural killer cells in destroying that specific threat. Yes, very exciting. This is a beautiful instrument because we can see that data visually, but we want to give you a number. So now we'll look at a graph and have a number that we quantify those results. 4-life transfer factor classic in this study increased the activity of natural killer cells 100 times more than without it.
Now you say 100 times.
Robin, you're great. We love you. So what we found on the 2003 study was an increase in 287 or 83%, if you remember that, with the trifactor, and 204% with the classic. And again, that was using not as modern technology. Now with the modern technology, and we replicated that study, we found that for life transfer factor classic increased the activity of natural killer cells 100 times more than without. And to me, as a scientist, and any scientist on the audience will relate to that as well, a good study includes what? A control. And that's what we did with this 2018 study. We compared for life transfer factor classic with a standard, with a control group. And that is the 32%, 32 times that you see on the graph. When we added the substance to the samples that we know that activates natural killer cells, that substance increased the activity of natural killer cells 32 times. But for life transfer factor classic increased it by 100 times. Okay, very exciting results. So now, as I mentioned, those two studies, we collected the samples from the participants and we treated those samples in a laboratory with the products. For Life has also performed a study in which the participants themselves took the product. And what we saw in that study was that 15 days or 30 days of taking For Life Transfer Factor Classic, the participants had an increase in the number of the natural killer cells, as well as the number of the T cells called cytotoxic T cells. Those two cells are very important in attacking and destroying the threat. Okay? So in different ways, what all those three studies shown to us is that For Life Transfer Factor helps the immune system respond to threats. Now let's move into understanding how For Life Transfer Factor helps the immune system recognize the threats. And we have learned from Dr. Parker in part 1, some of those cells, the most important cells of the immune system that help the recognition, helps to recognize what is you, what is not you, are the T cells. So those studies that we performed was to measure what happens with the T cells when we take For Life Transfer Factor. The T cells are very important types of cells, and I think it's one of my favorite ones of the immune system. Because the T cells are one of the only immune system cells that are actually transferred intact. The whole T cell is transferred from the mother to the newborn. And it's so important for the newborn, for the baby, to be able to recognize what is a threat, what is not me, and what do I have to destroy, and what is not. In this study, we use this methodology that is actually an FDA-approved kit to measure a specific type of T cell called helper T cells. In this study, we had two groups of participants. And the first group were people that have been taking For Life Transfer Factor products for many weeks. And in the other group, the participants have never been exposed to For Life Transfer Factor. When we collected the samples and we brought the samples to the laboratory, and we treated those samples with a substance that's called PHA. But the important thing to know about this substance is it is not the self, right? It's not part of the person, it's not part of our body. But this substance is also not a threat. So we want to test, would the immune system, would the T cells be able to recognize that this is not a self, but is also not a threat. In other words, will the T cells recognize that there is no problem, there is not a threat that I have to attack? So it's a very interesting study. And this is what we found. In those people that have never been exposed with For Life Transfer Factor, the activity of those helper T cells was very high. Those helper T cells were being overactive. They were over-responding and reacting to this substance. There was not a threat. There was no need to act upon. And in those participants, some of the participants, that they have been taking colostrum, not for life transfer factor products, but other colostrum products. And that's the third bar that you see on the graph. In those people, the helper T cells activity were a little bit less, if you can see on the graph. Not as overactive, but it's still overactive. And what do we see with for life transfer factor trifactor formula and for life transfer factor plus trifactor formula? Those are the last two bars on the graph. We see that the helper T cells were calmed down. They were similar to the T cells that were at rest. So those people that were exposed to for life transfer factor products, the helper T cells are able to recognize that that substance was not a threat, and they remain at rest. So those studies suggested to us that for life transfer factor helps your immune system recognize the threats. Does that make sense? Yes? So in summary, that's one of the points that I made at the beginning. That for life transfer factor helps balance the immune system response. It's not a simple just activation of the immune system. Overactivation of the immune system and constant stimulation of the immune system is also not healthy. We want to find that balance. Okay, so that is what that data tells us. Now we'll move to the third main point of our main claim, right? That for life transfer factor helps respond, recognize, and what? What is the last one? Remember. So we performed some studies to understand how for life transfer factor changes or modifies those antibodies, the immunoglobulins. And the immunoglobulins are very similar to the T cells. They are also transferred from mother to a newborn. Not the entire cell. As you learned in part 1, those antibodies are produced by the B cells. Not the entire cell is transferred, but all those antibodies are transferred to the newborn. So the newborn is then protected and can help the newborn remember what is a threat. Okay, now there are 5 different types of immunoglobulins. And immunoglobulins and antibodies are the same, they mean the same thing. We often use the words interchangeably. There are 5 different types. There's immunoglobulin type G, that you learned from Dr. Wollmer just now in part 3. There's immunoglobulin type E, D, M, and A. The immunoglobulin A, or IgA, is the one that we focused on our studies. For a couple reasons. The IgA is the most abundant immunoglobulin in human breast milk, out of the 5 types. So that suggests to us that that type of immunoglobulin is very important for protection in humans. And the second thing is the immunoglobulin IgA is mostly found in the saliva and outside secretions of the body. So it's a much easier sample for us to collect than having to collect blood from people, right? If we can just collect saliva to study how the immune system is responding, is the best way to do it. So we studied how for life transfer factor affects the IgA in saliva samples, and this is what we found. We have performed so far 2 studies. One was done in 2007, and the other one was done very recently in 2018. In the first study, the participants received for life transfer factor trifactor formula and real vida for 4 weeks total. In the second study, the participants received right start, either right start man or right start woman, for 12 weeks. And at the end of the study, we measured how was the change in the immunoglobulin type A, the IgA, in the saliva samples of those people. We found that after 4 or 12 weeks, the participants had an increased production in IgA up to 73%. So that data tells us that for life transfer factor is helping the immune system remember the threats. Because IgA, again, is one of the immunoglobulins that is a memory marker of the immune system. Does that make sense? Yes. Yes, also very exciting result. It's also a very recent result we just finished last year. Okay, I'm going back. I have showed you one of the studies that was the first time we ever presented that study. And I have another one. So the next study that I'll present to you was just finished a few months ago. We just concluded in 2019. And again, you were the first ones to learn about the study. Okay? We decided to put everything together. So we want to, in one single study, we want to understand how for-life transfer factors affected the response and how the immune system remember threats in one single study. This is what we found. After treatment with for-life transfer factor plus trifactor formula, we saw an increase in several markers. We saw an increase in macrophages. Remember from Dr. Parker in part 1, macrophages is another type of immune cell that is very important in destroying the threat and cleaning all those debris, all the cells that need to be removed from your system. So we saw an increase in macrophage. We also saw an increase in cytokines. And the cytokines are the actual substances that the cells themselves release up in their surroundings to destroy the threat. And third, we also saw an increase in immunoglobulin type G that was very specific to that threat. And this was after 4 weeks of treatment. Okay, so this is the first time we ever showed this study. We're very excited to share this with you today. And the last point is, again, going back to what you learned in the beginning, that all those benefits in the immune system, it's starting right in your gut. We were so interested in how for-life transfer factor is affecting the immune system or is affecting gut health that we performed a study to understand how for-life transfer factor can serve to benefit all the healthy flora, the healthy bacteria that is in our gut. This study was performed with all the probiotics that are present in the prebiotics. So this is what we did. We used for-life transfer factor trifactor formula, and we saw how does this ingredient increase or modify 5 specific probiotics, those 5 that are present in the product prebiotics. And we saw that the trifactor formula increased the growth of this healthy bacteria, 3 different types of bifidobacteria and 2 different types of lactobacilli, up to 868%. So what does that tell you is that for-life transfer factor serves as a prebiotic. It's helping your gut with a lot of benefits, and we know that 70% of the immune system is in our gut. Isn't that amazing? Yes. I found this amazing. So for-life transfer factor has so many benefits. All the specific immune system effects that we just learned, but also right there in our gut where the immune system is first encountered. So in summary, we learned how for-life transfer factor helps immune system respond to threats, and that was by stimulating the activity of natural killer cells, macrophages, cytokines. We learned that for-life transfer factor helps balance the immune system, right, with the T cells, so it's not just a stimulant of the immune system, but balances immune response by calming down the helper T cells when there's no threat present. And third, we learned that for-life transfer factor helps the immune system remember threats with those studies that we performed with an IgA. And lastly, again, the for-life transfer factor also serves as a prebiotic and helps with our gut health. Okay, we are going to get our last volunteer. Anyone interested, please come up. Thank you for volunteering. What's your name?
John Gonzalez.
John, you ready? Okay, they're gonna help him. Okay, John is going to ask for help. So the first question is, how does for-life transfer factor work? What is the mechanism of for-life transfer factor? Option A, stimulates natural killer cells, cytokines, and macrophages. Option B, balances immune response. Option C, increase the production of immune memory molecules. Or D, all of the above. What do you think?
The answer is D.
Yes, good job, everyone. All of the above. Okay, now, the next question is very tricky, so let's pay attention. In 2018, a recent study, 4 life transfer factors showed to increase the activity of the natural killer cells by A, 437%, B, 204%, or C, 287%, or D, 100 times more than without.
D, 100 times.
100 times more than without. Congratulations. Thank you, John.
Muito obrigado.
Thank you. Okay, with that, I would like to conclude. We just finished a lot of content. And thank you very much. We'll have our Chief Scientific Officer coming back on the stage. Thank you.
Please welcome back to the stage, Dr. David Wollmer.
All right.